Determine the equations of the tangent line through the point 8, 1 to the circle. So let's begin with the tangent line. So we will suppose that the tangent line will have a slope m and it passes through the point 8, 1. Now we can easily define the equation of the tangent line because we know the point slope form, which tells us that if a line passes through the point x1, y1 and the slope of the line is given by m, then its equation will be y minus y1 equals to m times x minus x1. Now in our case, the point is going to be 8, 1, so we have the equation y minus y1, which is 1, equals to m times x minus x1. So x1 is going to be 8. So let's simplify the terms. We get y minus 1 equals to m times x minus 8m. Or we have m times x minus y plus 1 minus 8m. So this is going to be the equation of the tangent line equals to 0. This is, we're going to label this as equation number 1. Now, we come to the equation of the circle. So here, the circle has the equation given by x squared plus y squared minus 2x minus 4y minus 20 equals to 0. Now this is this equation is given in the general form. We know the general form of a circle is given by the equation x squared plus y squared plus 2 times gx plus 2 times fy plus c equals to 0. So here we can immediately find out 2g, which will be negative 2. Value of 2f will be negative 4 and the value of c is going to be negative 20. So that means negative g will correspond to positive 1. Negative f is going to correspond to negative 2, positive 2. And c will stay as negative 20. Now we can define the center of the circle. The center of the circle is defined by the coordinates negative g comma negative f, which means we have 1 comma 2 as the coordinates of the center of the circle. And the radius will be defined by r equals to g squared plus f squared minus c. So we substitute the value of g, f and c. We're going to get the value equals to 5. Okay, so let's try to understand graphically what we need to do here. So we have the circle here. The circle has the center with c with a coordinate 1 comma 2. The radius of the circle is 5 units. We have a line which is tangent to the circle. We have defined the equation of the tangent. So that's mx minus y plus 1 minus 8m equals to 0. So here our goal will be to first determine the value of the slope m. So how shall we do that? Now if we drop a perpendicular from the point C to the point of contact, which is the point where the line is tangent to the circle, and name it A, then CA is going to be the perpendicular distance. And there's a formula for finding out this perpendicular distance. Let's say we have a point with the coordinates x1 comma y1, and we have a straight line whose equation is given by ax plus by plus c equals to 0. And then the perpendicular distance of that point from the straight line will be given by equals to, this will be the absolute value of ax1 plus by1 plus c whole divided by square root of a squared plus b squared. So that means in our case, we can find out the value of CA. CA is nothing but the radius of the circle. So this will be equals to the absolute value of, we'll have to consider the coefficient of x, which is m. This will get multiplied with the x coordinate of the center. So that's m1. So we have m times 1. That will be simply m. This will get added to 2 times the coefficient of y. So 2 times negative 1 will give us negative 2. Plus the constant term 1 minus 8m. Divided by the square root of, we'll have to take the coefficient of x, so that's m, square it and add it to the square of the coefficient of y. So negative 1 squared will be positive 1. Radius, we have already obtained, this value is 5. So 5 will be equals to the absolute value of negative 2 plus 1, that will be negative 1. M minus 8m, so that's going to be negative 7m, divided by square root of m squared plus 1. Now we're going to square both sides to get 25 equals to -1 minus 7m whole squared divided by m squared plus 1. Cross multiplication gives us 25m squared plus 25 equals to, we have to expand -1 minus 7m whole squared to get 49m squared plus 14m plus 1. Now 49 minus 25, that's going to be 24. So we have 24m squared plus 14m. Then we have 1 minus 25, so that will be -24 equals to 0. We can factor out 2 from each of the terms to get 12m squared plus 7m minus 12 equals to 0. Now to solve this quadratic equation, we can split the middle term. So we have 12m squared plus 16m minus 9m minus 12 equals to 0. So here we will take 4m as the common factor. So we have 4m multiplied to 3m plus 4. And from the third and the fourth term, we're going to take -3 as the common factor. So we have -3 multiplied to 3m plus 4 equals to 0. So this gives us 3m plus 4 multiplied to 4m minus 3 equals to 0, which gives us the value of m. So m comes out to be -4 divided by 3. And the other m value will be +3 over 4. Now that we have the value of m, we can substitute this back into equation number 1 to get the required equation of the two tangent line. So let's first substitute the value of m with -4/3. Then equation number 1 will become -4 over 3 times x minus y plus 1 minus 8 multiplied to -4 over 3 equals to 0. We're going to multiply throughout with -3. So the first term becomes +4x, second term becomes +3y, third term becomes -3. Then we have -8 times 4, 32 equals to 0. We get the equation 4x plus 3y minus 35 equals to 0. So this is going to be the equation of one of the tangent line. And if we consider m to be equals to 3 over 4, then we get the other equation 3x minus 4y minus 20 equals to 0. These are the two equations of the tangent lines. Let's use a graphing calculator to to understand the diagram. Here we start with the equation of the circle. We have x squared, then we have plus y squared, and then we have -2x minus 4y minus 20 equals to 0. That's the equation of the circle. Now we will consider the two equations of the tangent line. The first one being 4x plus 3y minus 35 equals to 0. And then we have the second tangent line 3x minus 4y minus 20 equals to 0. So here we can observe the two lines that are tangent to the circle, and also both the two tangent lines are passing through a common intersection point, which is 8,